In the spring of 2015, doctoral student Victor Perez was working with high school students and casts of giant fish teeth. And not just any fish, it was the monster of the Miocene, Megalodon, Otodus megalodon. During his time studying geology at the University of Florida, Perez had volunteered at a school in Tampa and another in Aptos, California, as part of a program that paired paleontologists with teachers. His job was to bring the scientific method into the classroom, and he had an extraordinary specimen to work with. A 3D printed cast of a nearly complete set of multiple megalodon teeth from the same individual, what's known as an associated dentition. The teeth themselves had been donated by private collector Gordon Hubble to the Florida Museum of Natural History just that year. For the Florida students, Perez had only a copy of the anterior part of the dentition, but by the time he got to the California classroom, he'd managed to get a copy of the whole set, anterior and posterior. I would say there's maybe a dozen known, such tooth sets around the world for Megalodon, says Perez, now the assistant curator of paleontology at the Calvert Marine Museum in Maryland. Larger fossils or complete skeletons of extinct sharks are exceedingly rare because shark skeletons are cartilage, more perishable than bone. So far, only teeth and the dense central part of vertebrae of Megalodon have been found. Closing parenthesis. With a name aptly derived from big tooth in ancient Greek, this enormous shark terrorized the seas from about 20 million years ago until going extinct sometime between 2 and 4 million years ago. Using the teeth, and equations based on the proportions of living shark species, the students should be able to calculate the size of Megalodon, Perez figured. An exercise that would be not only entertaining but instructive about an important challenge in paleontology: estimating the size of an extant. A paleobiology professor at DePaul University in Chicago and a research associate at the Sternberg Museum of Natural History in Kansas, Shimada had calculated that the particular Megalodon specimen he was studying would have been up to 15 meters in length. Longer sharks would be extremely rare, he concluded. Perez's exercise went swimmingly at first. The anterior teeth he had in Florida gave reasonable estimates of 12-meter animals. But when the California students looking at the whole dentition got to the back teeth, Megalodon had grown. Now the megafish was 45 meters long, almost twice the size of an average blue whale. As we're getting these different potential estimates, I'm trying to figure out if they used the wrong linear equation, Perez recalls. With the first section, of students in California, we didn't quite figure out why. By the second, we figured out it wasn't the students. It was the equations. This was surprising. Shimada's method was widely accepted, Perez says, with many other paleontologists relying on it when analyzing fossils. He presented a paper on the students' divergent findings at a conference in 2017. French vocational paleontologist Teddy Bedot saw the presentation and got in touch with an idea. Instead of tooth height, why not use width? 3 former Florida Museum graduate students sit inside a 3D printed Megalodon dentition, while holding a juvenile great white shark jaw. It was an idea Perez's colleague Ronnie Mike Leder of the Natural History Museum in Leipzig, Germany, had also previously considered. I was finally able to convince Victor, who was initially very skeptical, that this work would be quite significant, says Leder, who teamed up with Perez and Bedot on the project. Megalodon's best modern analog, says Perez, is the animal that might have helped drive it to extinction: the great white shark, Carcharodon carcharias. They then calculated a ratio of summed crown width to body length for each great white and applied each ratio to their single largest Megalodon tooth, an 18 cm tall, 13 cm wide fang from South Carolina, to get 17 body length estimates, then averaged them for their final prediction of the ancient beast. The new work, published in early March, also narrowed the range of body length estimates, posterior teeth stopped generating impossible giants. The most complete known associated dentition of Megalodon, with labels showing common terminology, scale bar 5 cm. Figure modified from Perez et al. 2021. On reflection, it makes sense that tooth width should provide a more accurate estimate than tooth length, says Syverson. He points out that the largest tooth of a 2.5-meter-long gray nurse shark, Carcharias taurus, known in the U.S. as a sand tiger shark, is only 3/4 the length of a tooth from a similarly sized longfin mako shark, Asurus paucus. Providing you have enough teeth, you'll naturally come up with a close estimate of the size of the mouth, using tooth width, says Syverson, which correlates closely to the size of the shark. I was quite surprised that indeed no one had thought of this before us, Letter says. Obviously the simple beauty of this method was too obvious to be seen. The approach does have limitations, though, in particular that it requires multiple teeth to produce accurate estimates, says Syverson. We can only use it for those sharks where we do have more dentition, but that's a quite small minority. Another limitation in estimating jaw size is that some shark species' teeth overlap, while others have gaps between them. Students from Lincoln Middle School in Gainesville, Florida, examine a 3D printed megalodon tooth. Photo by Kristen Grace Shimada, who updated his approach in a 2019 paper, including switching from a linear to a nonlinear equation that narrowed the range of size estimates for Megalodon, notes that the new study doesn't necessarily refute his results, adding that his work was based on different SP. Nevertheless, he says, the approach presented by Perez and others. Is a welcome attempt that further supports that Megalodon is indeed a magnificent animal. Shimada estimated in a 2021 study, based on growth bands in fossilized vertebrae, that newborn Megalodon were up to 2 meters long, already half the length of an average adult male great white shark. If this sounds like a lot of effort spent on a fish measuring contest, it is. But Megalodon is famous. It's on par with T-Rex, I would say, in terms of popularity and attention, Perez says. Enormity put Megalodon on the map, just as it did T-Rex, and so getting the size right is an issue of public trust in science, he adds. The size question continues to affect researchers' understanding of the shark's ecology as well. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.